Hello students, welcome to this lecture on the subject engineering mechanics. So in this particular video we will start with new chapter, that is coplanar non-concurrent force systems. Now what we mean by coplanar non-concurrent force systems. So we already know coplanar force system means all the forces that are acting on the body, they lie in the same plane. Okay. So here I have shown a few forces acting on the body. Now these forces constitute non-concurrent force system because as these forces are acting on this body, when we extend their line of action, now this force is going in this direction, this force is coming in this direction, the third force is coming in this direction. Now whatever may be the number of forces acting on this body, if the line of action of their forces do not meet at a common point, forces do not have common junction. Okay, so they do not meet at common point. Such a force system we call them as a non-concurrent force system. Okay, now what happens in case of non-concurrent force system is, now these individual forces tend to rotate this body about a particular point. Okay, so therefore when we start discussing about non-concurrent force system, we learn moment of force. Okay, because each force will try to rotate or turn this body. So in that case we have to identify the total moment of all these forces about particular point. So therefore we will now study about moment of a force. Though it may be easy to calculate moment or understand moment, we will learn this in a some different perspective. Now what is actually moment of force? It is turning effect. See, this is easy to digest, this word turning effect. Okay, so that is nothing but moment of a force. So mathematically we write it as force into perpendicular distance. This is how we evaluate moment. The SI unit is Newton meter. Now what is the effect of moment of a force? Effect, it is to turn or rotate the body. Okay, hence the body will either rotate in the clockwise direction or in the counterclockwise direction, anti-clockwise direction. So when we calculate moment, so the that force will rotate the body. Therefore the direction is the rotational direction. That means either we have to specify whether clockwise or counterclockwise. Okay, so what we just seen is how we calculate moment, that is by taking magnitude of the force and perpendicular distance. Now let us see this simple illustration. So here is the rod. Now this rod is hinged at this particular point. It is pin jointed. That means it can rotate about this point. Now when we apply a certain force here, now this force F is applied at a distance of x. Now this rod will rotate about this axis which is perpendicular to this screen. Okay, so this will rotate in this direction. It is anti-clockwise direction, counterclockwise direction, and its can say magnitude or the effect we can calculate by taking moment of this force F about point O. That means this force, how much turning effect it is producing. That means we have to calculate moment of this force about this point O. Okay, so moment of force F or turning effect of force F with respect to point O. Now this is how it is designated. M, moment of force F about point O. This is how it is written. So in all the numericals which we solve later, we will be using this particular notation when we calculate moment. So it is F into x, where x is the perpendicular distance. Now this x is measured perpendicular to the line of action of the force. Okay, so it is a distance from the point where we are taking moment up to the line of action, but taken in perpendicular direction, and F is the magnitude of the force. Okay, now let us see some calculative approach of understanding moment. It is not big analysis, but this will help us to know moment even in a better way. So I have listed three cases. The first case, you see, I have taken some value for force 20 Newton and perpendicular distance I have taken 5. So if we evaluate, it is 20 into 5, 100 Newton meter. And what is the direction of this moment? It is clockwise direction. It is clockwise direction. This is how we write clockwise direction. Okay. So moment is a vector because it has got direction, and that is either clockwise or anti-clockwise. Second case, the same force 20 Newton is acting at this point. It is not acting here, it is acting at this point 3 meter from point O. So if I have to calculate moment of this force with respect to point O, it will be 20 into 3. 20 into 3. The direction is of course clockwise direction. Now the value is 60 Newton meter. Now when we compare this with the case 1, this is less turning effect. Okay. So this force, you can see the same force, instead of acting at this point, it is acting at this particular point. What we get is the less turning effect of the rod. The rod will have less turning effect. Okay. Then when we compare with the case 1, now this will be having more turning effect. The third case, I have taken the same distance x, it is 5 meter. Now we have reduced the force, it is 10 Newton. Now the turning effect or the moment of this force about point O is 10 into 5, 50 Newton meter. Of course clockwise, less turning effect. So what we understand from this simple calculation is that if we want to have higher turning effect, if we want to rotate easily, you can say higher turning effect. Okay, so we can either increase force F or we can increase X, or both of course. But in most of our situation or application point of view, we don't have a provision where we can increase F. Okay, so what generally is done is X is increased. This perpendicular distance X is increased in many applications, and thereby we can have a higher turning effect. Okay, now let us see some application point of view, the common observations of moment or turning effect. Now here you will understand. Now it's a simple door, it is hinged here. Now here is the handle, door handle. Now this door handle, you see door handle, it is not actually mounted near to the hinge. Okay, it is, you have never seen a handle which is mounted near to the hinge. It is always away from the hinge, because I will now see, this is the hinge, this is our point O, this is the perpendicular distance x. So when the handle is mounted much away from this hinge, we get what? Maximum turning effect. So F will be acting perpendicular to this door. So a person will come and try to apply this force F. Okay. So we cannot increase this F unnecessarily. Okay. We want to apply minimum force. We just want to push or pull. We want to apply minimum force F. F, we want to keep it as minimum as possible. This is our effort. And we have the option or provision where we can increase this X. How? Just by putting this handle away from the door hinge, and thereby the ultimate what we want is the turning effect we can increase. That means we can open or close the door very easily. Okay, if we reduce the X, if we mount this handle here, then we have to put extra effort, extra force we have to put to open or close the door. This is very simple, you can say, observation. Similarly, this is another example you see. This is a scissor type jack, screw jack, mechanical jack, which is used to lift the cars. Okay, now the weight of the car in terms of kg, I will write it is approximately around 1000 kg. Okay, so you can imagine, to lift this 1000 kg of car, a person of average weight around 75 kg, the weight of the person, he will easily lift this 1000 kg weight. How? By using this mechanism. Now what is the concept in this mechanism? You see, without this rod, you can see this rod, without this rod it is impossible to lift this car. Okay, what is done here is again the turning effect M, F into X. So this F is applied at this particular point with the help of hand, this F, which is minimum or sufficient. Sufficient means an average person can apply, okay, some amount of force he can apply. And because of this x, which is a long rod, it's a long rod, x is nothing but it's a long rod. So because of this higher value of x or longer rod, we get what? Higher turning effect. So if I can turn this somehow, if I can rotate, it's a screw, okay, it's a screw. If I can rotate, then this mechanism will work. So if this rotates, this will move in the upward or in the downward direction. So that's very simple mechanism. That is the application of you can say moment, and we can easily understand how helpful this moment is for us. Okay, so hope you have understood the meaning of moment. You can see other you can search in the internet, you can see other videos to understand more about the moment. But what we will be doing in the next videos, we will see how we calculate moment of force for different cases. Okay, so thank you for watching this video.